Hi, everybody. This is Kubernetes Workgroup Device Management meeting for January 6th, 2026, our first meeting of the new year. So happy New Year, everybody. Let's get started. Let me share this document. Okay. So first thing we had on the agenda was just to start going over what we're planning so far in 136. I have this document. We've used the last couple releases, and we've updated it. There's a lot here, and not everything is even here. There's, I believe, things here. I mean, these are the DRA things. There's also workload aware scheduling items that are primarily run out of SIG scheduling, but we have some involvement. Most of these are probably familiar to people. I won't go into all of them, but I would ask each of you, if you're an owner on one of these, which many of you are, please make sure this is accurate. This is what will kind of make sure things get tagged for next release and things like that. There's a few new ones on here. This one, probably not everybody's seen, but we have a volunteer here to run it. He's already put together an initial draft kit. I haven't had a chance to review it yet, but please take a look at that if you have time. And unless there's other questions on this, I don't necessarily want to go through all of these. We've been through them many times, but if there's specific ones you want to discuss here, please call it out. The other kind of call out thing I wanted to do is on the workload aware scheduling piece. So what was implemented in 135 has a concept of pod groups in a workload, but they're kind of they're essentially a place to attach policy, and then they're inferred from information on the pod. And one of the problems with that is that from a DRA perspective, there are types of resources that we would like to be able to allocate for a pod group as opposed to for an individual pod. So we've talked about this with jobs and job set and leader worker set. And the way the workload aware scheduling pod group is implemented today, that means that those that a controller, like maybe the resource claim controller, that was watching those workload objects would have to infer from something like pod in the same way that new pod group replicas have been created, because the pod group replicas aren't really tracked. You might be able to calculate it from the workload object, but I'm not even sure that that's true. So one of the proposals that wasn't implemented in 135, just for scope and management reasons, is that the pod group replica or pod group itself should be potentially a separate top level resource that gets created and managed and life cycled, and then we could tie resource claim life cycles to it, just like we do to pod life cycle, much more easily. So we'd have ones that potentially could tie to workload life cycle, ones that could tie to pod group life cycle, and ones that can tie to pod life cycle. I think that makes sense to me. And but if you're interested in this topic, and I know some folks here were, please take a look at this document, Wojciech. It's really just a place to facilitate discussion. Like you'll see, he did this right before he left for vacation and before the holidays, and just said, hey, here's some of the things we have to think about in order to make this decision. we do think it's going to be a challenge to make this decision any later than this release. So that's kind of where we stand with that. Those are the only two items I put on the agenda, and so I'd be happy. I don't know who put controller support for workload API on here, and I'll open the floor to that, and then we'll move on to the other ones. Oh, I see hands are up. Sorry, I wasn't on that screen. Who's first, Kevin or Kevin?
I think I was first. Yeah. Okay. What was I going to say? Oh yeah. So I guess I haven't read this document yet, but I'm trying to wrap my head around why having a separate object for the pod group helps in this case. Why can't it just be tied to the workload?
Okay, so if a workload consists of pod groups, and
multiple pod groups.
Yes.
Okay, so that answers the question then. Got it.
Okay. Okay.
Yep.
And you could potentially calculate from the workload object, at least in some cases. I'll just say this: in some cases, you could calculate from the workload object when a new pod group comes to be, but if you like right now, actually, I think in 135, it's sort of like when you scale it, right? It might add replicas, but like of the pod groups, but like, does that mean you have to scale from the top or bottom? Like, can you pull one out of the middle? Because we have to deallocate a specific resource claim if you were to say delete a pod group in the middle, right? And I'm not even sure it tracks it. It does keep a replica key, so maybe it tracks it well enough to do that, but it's unclear to me because it's kind of implicitly gathered from pod information, from what I can tell, rather than explicitly created by controllers.
Got it. Yeah, I'll make a point to read this soon.
Okay, cool. Thank you. Kevin H.
Yeah, I guess I put this here because I saw we were going to discuss workload API. I was under the impression that this was the group where the workload work would go. I mean, I guess basically what I was working on was trying to see how stuff like job set and job can consume the workload API, and I kind of proposed a KEP for that, but then there are so many things in flight with the workload API that like for job set and leader worker set, I'm almost tempted to have like a workload template that kind of future proofs the API changes, because like I know that there's DRA support for workloads, and one of the initial ideas was just to kind of have a simple Boolean or a flag that kind of creates the workload object under the hood, but that kind of breaks stuff like topology aware scheduling and DRA. So that's kind of where I was leaning towards, but I don't know if it doesn't sound like.
I mean, this is sort of that place, but we didn't specifically, like a lot of it's being done in SIG scheduling too, because this is kind of, we're kind of coordinating this work out of there, but which is auto scaling and Node and DRA and other things.
I mean, the reality is this should be a working group, but a separate working group in itself, but that's fine. The people that I'd want to talk to are not on this call, so we can table this one and I'll figure out a place maybe to discuss this.
We can put together an ad hoc call, maybe. Does anybody know? I haven't looked yet. What is the cap freeze date for 136?
The link 404s right now, so the release 1.36 is 404ing, so I don't think it's up yet. Looking back 3 releases ago, which I guess doesn't really translate, it will probably be sometime in February, to be honest with you.
Yeah, the release team hasn't even opened a PR for it. So yeah, I think mid-February is what I'm thinking.
Okay. Just so we can, because there's a lot of work to do on the workload aware scheduling side to define and make decisions and designs, as well as on everything else we're doing. So, but let's Kevin, do you want to coordinate with Eric and Wojciech and I mean, whoever else.
Yeah, I mean, where I guess I will post maybe on SIG scheduling to, kind of, because, I know that Hiba opened up a kind of a design about how controllers could leverage this, but there is a lot of other people also working on this. I sort of stepped on some other people's toes too. So.
Well, I just think we want to figure out something. It's just it's like you said, a lot of different moving pieces, and so trying to bring them into a shape where they all fit together is hard.
Yeah. Okay. I will. Yeah. I'll start a thread or something to maybe figure out, like where that discussion is happening. Maybe I'll try to attend the SIG scheduling meetings. I know that's where most of them are.
Okay, that sounds awesome. Yeah, and then take a look at that document too. I think you'll find it interesting, probably. I mean, it's really just like a here are the things we have to think about, and then Eric put some more stuff in. So we'll see. Okay, what do we have next? Sebastian, is that Sebastian?
Yeah, that's for me. Just wanted to see if this one is something that it's interesting and there are other use cases for that idea. So as a maintainer for the DRA driver for SRV, one of the use cases we got here is about bandwidth allocation, but the thing is like bandwidth is per PF, like physical function, and not the virtual functions that we are publishing in the resource slice. So using the consumable device on the VF will not help us with bandwidth allocation. So I was thinking having like a connection, like putting consumable inside the partitional device. So we're going to configure like the PF as a partitional device with consumable max bandwidth for networking, and this one will be reduced every time someone allocate a VF and request, I don't know, 10 gig, 100 gig, things like that. So wanted to know
that they were designed to be layered together to work like that.
Yeah, but we're missing a connection point, Kevin. So what we're missing is a translation from the consumable capacity to the counter value, right? So in your original design, you had those always the same, and we separated them, and that was intentional because I didn't believe there would always be one-to-one, and so what we didn't do is we didn't build the bridge.
A way to map them back together. Okay, yeah. I see.
So Sebastian, a couple of things there. So when you do so the VFs, okay, for SRIOV, it should the capacity constraint on the VF is variable and basically can be whatever the user asks for, and it needs to consume from the PF. So we don't know up front the amount of capacity consumed by the VF. That's what you're saying, right? We don't know.
Yeah, exactly. Exactly. You can have like 10 VF, but then if you have like a NIC of 100 gig and one DPDK application requested the full 100 gig, so that's it. The PF is full, and we can allocate VF from another PF, for example, and that's what we need to do to not overload the network and start having like performance issues from networking point of view. So that was my idea. If I can have like the consumable capacity on the parent one, that can be good.
Are the VFs actually different? What if you just have one device with a consumable capacity of 10 VFs, virtual functions, a count with integer, and then you basically allocate always one VF from that physical function device and together with a capacity of the bandwidth?
So on that one, so I'm also working for a scalable function, DRA driver. So on that one, that's more easy. I'm using like the consumable capacity because I only have like one device. Like I only represent the parent one, and that's it, because I can create scalable functions up and down as much as I want. But for virtual functions, that's not the case, as like every virtual function is like a unique device. I'm passing PCI address, for example, or if it's a Mellanox device, I'm even passing RDMA InfiniBand devices into the pod. So I cannot group them in the resource slice as only one device with 100 capacity for 100 virtual functions or 100 gig for bandwidth only. I need like every one of the VF to be separated in the resource slice.
Yeah, it's interesting because, sorry, just one thing I want to add here is I was actually thinking of bringing something else up, which may help in this case related to how we do partitionable devices and so on. So let me just throw out a different use case, which I think is related, and see if the solution that we kind of came up for that would also work here. And it requires an extension to the partitionable device stuff. But the problem we were running into is we want to be able to basically take a device and partition it different ways, right? So you can either have a full GPU, or you can have a GPU in as a VFIO device, or you can have it as a set of MIG devices, or you can have it as a set of MPS partition devices, or you can have it as a set of time sliceable devices. And right now, there's no real way to do that. It's okay if we jump between full GPU, VFIO device, and then one kind of long list of partitions. But the minute you have some other one that actually partitions it into a set of different partitions, you can't allocate one device from one partitioning scheme and then tell the scheduler somehow to never allocate from the other partitioning scheme going forward. Because there's no way to kind of mutually have some mutual exclusivity to say that from now on, I'm only pulling from this partitioning scheme. And the reason I think this might relate to what you're saying right now is that if we had something about this that said make these different partitioning schemes mutually exclusive, we could basically partition your thing up in a way to say, you know, once you've allocated this device as this virtual function, from that point forward, I can only consume that device's consumable capacity. And so you could have a list of multiple of those, but there'd be no way that you would ever pull from a different one later, if I'm understanding the underlying issue that you're saying.
I have to say, I think it's a bit different because here you have like schema. In my case, I have like bandwidth. It can be 1 mega, it can be 400 gigs. So I need like a way to say that it's consumable, like resources, like CPU and memory on Kubernetes, like for pod. Mm-hmm. So I think it's like a bit different from schema.
So sure, but that's for the consumable capacity side of it, right? But yeah, okay. Go ahead, John. Sorry. Yeah. So what I was going to say is I think there might be a mechanism here that might help in both of those cases, which is a sort of it's basically building on what Patrick said. So Patrick said, "Hey, let's add another counter or consumable. I think it would be consumable capacity that counts the number of VFs available, assuming all the VFs within a PF are identical." If you did that and you had a way to implicitly consume that capacity when you chose that type of device, it would be similar. Essentially, the user wouldn't have to specify that thing, but it would get consumed. So in your case, Kevin, you'd have for each partitioning scheme, right? There would be, maybe you could do this with a counter set there. For each, you'd have a counter for each partitioning scheme with a value of 1, and actually, when you choose one partitioning scheme, you would consume the others, something like that. You might be able to tweak it. We thought about this a bit. The problem is that the minute you allocate the first one, that's fine. It takes the other ones away, but it doesn't take all of them away. Right? I would never be able to allocate another one of that same partitioning scheme because it's now consumed everything from those others in that first one that I allocated in order to make sure that none of those could be consumed. Okay, we'll have to look at it. I wonder if there's a few other mechanisms. So the short answer, Sebastian, I think is yes. Like this is a super interesting problem to solve, and there's a few different ways we can model it, and we have a few different tools, and we have to figure out how to tweak them to make it work. The other thing I wanted to ask about is, in your case,
So if you think about the case, and sorry, Antonio, I see your hand. The other solution I was thinking about or possibility is we've talked a lot about or a bit about in some of the issues, especially in reference to the binding conditions. We've talked about the idea of template devices and provisionable template devices that don't exist yet. And in some sense, the consumable capacity, when implemented with provision sub-interfaces, is doing that under the hood without exposing it to the Kubernetes API, where like you ask for 10 gigs or 1 gig out of the 10 gigs of bandwidth, and it will provision a sub-interface in the kernel, and then configure it to be limited to that amount of bandwidth. That interface wasn't advertised directly, right? It's a new interface, and it's represented by that resource claim associated with the consumable capacity. In your case, since the VFs, they're almost, you could almost like do the same thing implemented with the VFs, but I think your problem is you're going to run out of VFs, and you don't currently have a way to control or limit the number of people that can consume that underlying resource claim. So that's another avenue to think about, is maybe it's not connect consumable of the VF device to the consumable or counter set of the PF device. Maybe another way is to think through, is there a way to limit the consumption or creation of resource claims on top of that original PF and implement it under the hood like we do for those sub interfaces. So like there's probably I think we've talked about at least 3, maybe 4 different ways to model it right here. So we should like explore this a lot more. Antonio?
Right, on the original step, right? That's the one that we were putting this specific use case of defining bandwidth with the consumable capacity. So I really, when I get lost is when we start to mix PF and VF. Is that this is a single device that is modeled as a one-to-n sub-devices, or I mean, why the existing consumable capacity doesn't work? I mean, why VF has to be related to the PF? So those are the kind of questions. Do we have clear the abstraction of devices here, and we cannot use existing consumable capacity?
So maybe I can give like a small thing about this one. So the idea is like what we are doing today is that on the resource slice, we are publishing the VF itself, not the PF. And the reason we are doing that is that like every VF can have has its own PCI address and things like that, all that information that we need to pass. So the idea was to not have the PF as a resource with the amount of virtual functions. If that can be like another solution, maybe we can try and look that way. But we wanted to have them like separate, like the VF separate, because we can have some of them in InfiniBand mode. You can have some of them on VFIO mode, things like that. So that was the main reason why we decided when we create the DRA for SIRV to represent in the resource slice the virtual functions itself and not the physical function. And the general use case that we have from a customer is said that he have 4 100 gig NICs connected to the same network. For him is the same. He allocates 124 virtual functions on every one of the PF, and then it's he want to give that to the user, and the users can start allocating workloads. He doesn't care if someone allocates 4 workloads of 100 gig and that's it, and all the other virtual functions can't be used because you are full on bandwidth, even that you have spare virtual functions, or you have 100 small workloads using 1 gig every one of them. So that's the use case that right now we don't have a good solution for him.
Okay, that's a lot of useful information, and I think that we build from your specific use case it's going to be way simpler. But what I'm afraid, honestly, that this kept from consumable capacity, it's an alpha. It won't postpone to alpha, and if we derail it or we deviate,
No, I would,
we
Antonio,
stay
I
in
would do it as a
perma alpha.
separate, I would do it as a separate cap. Like that
Okay.
one's that scope is defined and contained, and I think it's done.
Okay, that's you
Let's
understand.
advance it. If we need to make a connection, like we'll make that connection in a separate cap.
Okay.
Morton?
The same applies to partitionable devices also. We aim to get it to beta in 136. So especially Kevin brought up from NVIDIA, like that'd be useful to see if that impacts like what we want to do for 136.
But it would be its own feature gate. You wouldn't block partitionable devices.
Okay.
Yeah, for sure. It should be on its own feature, for sure.
Yeah. I think for both partitionable and consumable, like we need to figure out if there's anything that blocks us from going to beta, something we can't push into another cap. So.
Okay, awesome. Yeah, really good use case, Sebastian. So what I would suggest is the next steps is, Sebastian, if you can write up your use case as much as is permissible, and and maybe Kevin, you as well, if you've got this, yep, and we'll try to look through alternate ideas of how to model, what's the minimal change we can make that makes the maximal impact on all these use cases. That's kind of the goal. So we've got at least 4 or 5 different options we've discussed today.
Yep.
And so let's, that's the next step.
Just to me to understand, as I'm first contributing to this one, so open an issue to the Kubernetes repository. That's the good place, or there is a different place?
I would open, you could open an enhancements issue right now if you want, but I don't think we know well enough yet the solution. So what I would suggest is we start with just a Google Doc with your use case, and then shoot it over to the group, open it to the group, and send it to us all in Slack. And Kevin can either have his own doc or add to that doc, and we can kind of try and get a nest of things we think are potentially solvable by the same or similar solution, and we can try to list the alternatives. And then once we have a better idea of actually the way we're going to do it, I would create the enhancement issue then, just to avoid extra paperwork.
Yeah, sounds good.
Otherwise, we'll end up with multiple enhancement issues, one of which gets obsoleted.
Okay, awesome. Okay, thank you, Antonio. So Antonio and Sebastian will come back with something on that. Yeah, excellent, great. Let me go back to the agenda. Okay, Ale, are you here? You're probably here.
Yes, I'm here.
You're next.
Yeah, can you please click that link I just pasted, the README, the second one, sorry. Yeah, so I wanted to discuss the downward attribute API design doc. In the last call, we discussed the design a little bit, and we had moved away from making changes into the kubelet and just use the DRA driver as a basis to mount a CDI spec file. However, in that discussion, there were 2 open questions. One was that how would the application pod know that the metadata has been mounted and it can read from that? Or maybe how would anyone in the system know that this device driver supports downward API, because it is then going to be specific to the driver? That was one question. And the way I'm trying to answer that is through this directory structure here. So in this directory, you see there is the first directory is supported. in that there is a list of drivers that support this. So whenever a driver that has this downward API attributes JSON set to true in its invocation of the plugin, it will create this particular empty file. So in this case, example.com under the .supported is created. And then the whenever a claim is processed, the claim will have the namespace and the claim name as a separate directory. And there it will have driver names and the metadata.json. So what an application can do is from the driver names, it could go into the .supported and find if that driver is indeed supported or not. And if it is supported, then it will look for that metadata.json and find all the relevant argument, like all the relevant information there. This is one way I could think of. This avoids any change to the existing API. So we don't have to change the resource claim status or pod status to reflect whether the driver supports downward API or not. I see we have hands raised, so I'll pause for questions.
Yeah, first thing, you're saying the framework creates that, but isn't that a directory that gets injected by individual DRA drivers? So which of them owns the .supported directory?
The framework will own the .supported directory and it will mount the CDI spec.
Which framework? What is the framework here?
The plugin code
yeah, but that's by DRA driver. So you have two DRA drivers on one node. Both of them would conflict. Both of them would try to mount something under var run DRA device attributes. So you could have something mounted by a driver. Yeah, but basically you are now describing a world where one instance populates DRA device attributes, but that's not what we have. We have multiple DRA drivers, each providing some piece of that information.
Yeah, you'd have to like put it on the host somewhere and then mount that one host folder or something if you were to do this.
Yeah, that's what I was showcasing here actually. Is this is going to be the host directory and this gets mounted by each. And it is a shared directory that gets mounted by all supported downward API supported DRA drivers.
Yeah, but then you have a conflict on the driver names file.
No, he's saying that there be he's saying there be a folder on the host, var run DRA device attributes. I don't know where it needs to be on the host, but he would have a .supported subfolder in it, and then each DRA driver would put their driver name as a subfolder in these places, and that's going to be on the host. And then the only thing that each driver would then map in is the top level directory mapping to var run DRA device attribute.
Well, you can't do that. And every pod has access to every claim, right? So you have to only mount the claims that are.
Yeah. So I was thinking of just mounting the var run DRA attributes .supported and the specific claims that got assigned to that pod directories. So
you could see, you'd see everything under .supported, but then you'd only see the claims that you had access to.
So you'd have information about what drivers are running on the node, but and support this, but that's not really secret.
Yeah, and well, the only intention for this was to avoid any changes. So the application will learn from the directory structure. From the claim name, they would find the driver names that support this. Then they go into the supported directory, find the name of the driver. And once they are there, we have the metadata.json that the application can look into.
Yeah. So what is why is the .supported necessary?
Because the application doesn't know the driver for the claim that it got handed over to, right? So it has to find a way to learn the driver name, and that's where it will look at the driver names directory to find all the drivers that support this.
It doesn't really need to look in .supported because it can just ls the driver names. You can read that directory, and
it's still not clear. It's still not clear to me who writes the content of the driver names file.
The driver names file is written by the same component that populates .supported with its entry will then write it when the claim is processed.
I mean, it might be written by multiple drivers. They're just,
right,
it's like,
right. One claim could have multiple drivers. That's why we have multiple names. And which of those different drivers writes driver names? They don't even know about the other drivers.
Right, they each write themselves to that, right? If they check if the directory exists, and if it exists, is that a file, or that's, oh, I see, one driver per line. Now, that probably needs to be a directory so that the file system manages the atomicity, and then they can just add entries to themselves.
Yeah, I realize now that I'm discussing this out loud, it is turning out to be more complex than I had initially envisioned.
That's why we're discussing it.
Yeah, I kind of don't like the fact that in order to support this, we have to come up with so many files. I feel there should be a more graceful solution.
Antonio?
I just was going to say that this is a good discussion, because my point later is set about this. We wanted to add a status to the resource claim. We thought that was simple, and now we need to expand the cap because we need to. The security folks told us you cannot have a driver writing all the other drivers stuff and all the stuff. So yeah, it's a complex topic. How to handle the relation between drivers, resources, slices, and devices.
Yeah. Okay. So I think one concrete feedback is that the driver names can conflict. So one potential way out of that is maybe we can convert that into directory, and then the driver writes its own name as a separate file. That theoretically could work. I'll try to brainstorm a little bit and see how far I get with that.
Sebastian has a hand.
Yeah, I just have like a question here, because we are implementing something a bit similar for the DRA in the meantime. We are waiting for this one. It's also critical for telco use case from my side, at least. They need to get the information on what network is connected where. So my general idea on the pod side, what we are planning, at least until this feature is available for us on the SRV DRA driver, is to have the name is like claim name and then the request name. And inside of it, you can have a list, because of course you can have multiple of them. And the reason is because every request is only bind to one driver. So you can, on a claim, you can have multiple drivers, but every request only it's point to one driver. And my idea was to put inside the pod, you have a folder, but on that folder, the files are just claim name and request. And inside, if you request from the same device 10, for example, virtual function, so it's a list with all the parameters, attributes, and data. That's at least what we are going to implement as the first stage for the SRV DRA. And on the host, we are doing more or less the same. So we have the file on the host is the claim namespace, claim name, and the request. That was the way. Also on the host, we don't have a collision between different claims on different namespace and things like that. So that's on the host. Inside the pod, we just remove the claim namespace, because that's another variable that I don't want the pod to need to know about it. It should only know like claim name and requests. That was my idea. I didn't know about that support folder. I'm not sure why. Maybe I didn't understand it fully, but not sure why it's so critical to know which drivers implement what?
So the reason why that is important is that so there are two states that the application need to differentiate. One, that the driver supports downward API and the metadata.json is not present. So that is an error state that application needs to know. The other is that driver does not support metadata downward API, and hence the metadata.json is not present. So,
but you're still stuck, even because if the driver doesn't write metadata.json, it's probably not going to write the driver name, and so you're still in an error state. You can't differentiate.
Yes.
Right. I mean, presumably something borked in the driver if the metadata.json, unless there's a race condition that could, I mean, it could mean wait. I don't know. Like, but I don't remember the details enough. But you see what I'm saying?
Yes. So if I revert that, the fact that driver names get populated along with the claim processing is problematic because that claim processing itself could be borked, and we will not have driver names in that directory. So this might not work.
Yeah, if that's supported or written by the kubelet or something, then you'd be, but it's not going to know anyway. So the other thing this starts to hint at that I would want to think about too, not to make it harder, but is like, if we decide we need a supported thing, are there other things that workloads need to discover about drivers and what they support? And if so, maybe there's a solution that, like a discovery about drivers information. I don't know if we need that or not. This is like, when I see a one-off, it makes me think, well, is there more, right? Just something to think about. But
yeah.
But by the way, I don't know like how hard and impossible this be, but can it be added as an optional into the node prepare gRPC where the driver tells like kubelet if it support the downward API or not, and it's going to expose it or not? I don't know how hard it is to change the gRPC that already exists.
Well, the issue is that the fact that the driver supports this or not is a one-time communication. So we can do it when the driver starts, but the claim processing is a pod time, multiple time communication, right? And that communication could be broken. And the only thing that the pod knows is the claim itself. From the claim to resolve to the driver name, it needs to look up the resource claim object, and that lookup is something we are trying to avoid. So I'm not sure how passing the information from the driver to kubelet, whether this is supported or not, will help avoid this issue.
So I can say, like, in theory, if like when the driver connect, we say that we support downward API, and then on the node prepare we don't provide this one, then the pod should not start, like not having it as a best effort. It should be there. So if the file is not there, if the problem is in the driver or something like that, the pod should fail because the application will not have the needed information to start. So it's really not useful. Only if the driver said that is support downward API.
I see. So you're saying when the driver starts, we register it that this is supported, and then from the node resource, we pass in something to the plugin or the kubelet, that plugin framework or the kubelet, that the metadata was populated, and so this continues. If it was not populated, we can error out there, and this will be an error case. Retrigger everything, reprocess this claim.
That's at least an idea, but I'm not an expert here at all, so I'm pretty new. So just a general comment.
I think that could work. I'm not sure if others have thoughts where this might fail.
Well, you might upgrade or downgrade the driver, and one version might support it and the other doesn't. So it's a bit more complicated than a driver always supports it.
No, but it's if it tells the kubelet at registration time, then when you downgrade or upgrade, you're going to get that information, right? It re-registers.
Yeah, but if we get the kubelet involved and it always writes this supported file or whatever, yeah. But
Well,
when we are back at modifying kubelet, which I thought we wanted to avoid, because that is a long road.
Sorry, I think we can still do this in the framework part, which makes the call, right? We can avoid kubelet and make this in framework and have the error be raised there instead of in the kubelet.
The registration, though, is with kubelet. So if there's information we want to include in the registration, we need to change kubelet to accept that information and do something with it. If we don't,
no, I think the registration then would be with the framework. So the driver author would just have to pass this argument to the framework, and the framework will know whether to validate or not. So
my point was, if you have a driver version which has a framework which doesn't know about this whole code yet, and you install that version, you don't get the .supported file. You upgrade your driver, it now supports the feature, and then you downgrade to the previous release which didn't have it. The .supported file will remain in that case because the old version of your driver doesn't know that it needs to remove it.
Yeah.
Right? So we
yes,
have
I think so.
we have stale information basically in that directory because no one knows that it needs to be removed. It's a minor thing. We could just say, well, never downgrade my driver. If you don't need the feature, disable it, and then the framework can remove it. But that is something that in a KEP would need to be called out in the upgrade downgrade scenario section and all of that. And it's doable, I think. I'm still not sure what the .supported actually provides to the application. So the error handling is not clear to me, but I haven't read through the entire document again.
Yeah, it was just an attempt to differentiate the state between this driver supports and the metadata.json doesn't exist versus this driver doesn't support the feature and hence the metadata doesn't exist.
Mm-hmm.
Whether or not that is needed, we can just go back to a very safe case where if the driver supports and the metadata.json doesn't exist, it's just a failure. And we'll not be able to start the pod. We can.
If a driver supports the feature, it could just always write the file and just not put any information in it if it doesn't have anything.
Yes. That could.
The overhead shouldn't be high, right?
Yeah, but then when does the pod decide to fail? When does the pod decide to fail? Right? Like,
yeah, well, if it needs the information, it needs to fail if it's not there.
Are there cases, Ale, where you're trying to say, well, we don't really need the information, we just like to have the information?
But I don't know about the telco case, but at least in KubeVirt, if this information is not there, that means you'll not be able to configure the device properly, and hence will just fail. The only case where this could be problematic is if somehow the information arrives later in the state. We were discussing, Sebastian and I, on a KubeVirt call that there could be some networking information which arrives later than the node prepare call. And in that case, we would not know like if the absence of information means to wait for it or just fail.
Okay, sorry, Frank, but it's the problem to get the resources locally, because this information, you can watch this information, right? So I think that we are focusing on the downward API, but I really want to understand is where is this information and why you cannot get it from another place?
So the information is PCI address, which is the attribute of the device. In other cases, it would be like in the case of mediated device, it would be MDEV UUID. And I'm not sure if those will be available like on the local file systems. It is something that the driver passes through when it made the allocation on the node.
I think I could go even with a simpler use case, Antonio. So you have 4 virtual functions. Every one of them is connected to a different network. So you need to pass from the resource claim, you need to do the connection between the PCI address to the name of the network or the name of the request in the resource claim that you gave, network red, blue, green, things like that. So we need that connection. PCI address, I can access the PCI address from inside the pod, that's not a problem. But when I have more than one, I need to know to which network every one of them is connected. That's the bare minimum information
of the. You're saying that's an attribute of the device the device.
It's even after the attribute. That's something that like we are adding to the network into the network. So yeah, it's an attribute for the resource claim inside the VF. So every one of the network is represented as a resource in some type of network. That's at least for DRA. So
okay.
that's
so
one
thing I would this is a total aside, but I don't know if we've talked about it before, Sebastian. One thing I is that, well, I'm not going to go. We'll talk about that later. But on the arriving later, so arriving later to me sounds like it's not part of the DRA driver, because the DRA driver is out of the loop at that point. So that almost sounds like that's a special case whereby maybe you put a marker or a sentinel that says, hey, you should wait for this. And then there's some out of Kubernetes band protocol that you've got with your, it's like if you wanted to do a DHCP request or something, right? Like you're going to wait for that. Yeah.
So I think for that one, and again, we try this, we try to play with this one, and what it mean like on a later, we didn't manage to make it like to showcase that it came later. So I will explain. The idea is like we have the DRA hook when we are creating the resources, but that's like half of a part, especially for network devices. Then we have a second part that we have an NRI hook on the pod sandbox create, and that's the place where we are getting PCI address and all that networking information, and that's what we are writing the file. I have to say that I checked the Kubernetes and CRI-O code and things like that, and was not able to find a race on a place where we create the file on NRI hook, but the pod will not see that information. So this one is like a race that may happen. I was not able to validate this one. I ran like 100 times a test doing this with my DRA driver, and every time the millisecond the pod start, all the information was available on the CDI, like on the file that was injected into the pod. So I was not able to reproduce, but maybe on high scale environment, things like that.
No. There is no race there.
Yeah, it can't happen. I'm almost sure it can't happen, but wanted to be on the safe side.
It cannot happen. The NRI is serial. All the process of the hooks are executed. So you don't move from the NRI hook to the next part. It's blocking
for all the containers, are all the NRI hooks called before the containers are actually started?
No. That's okay. I know oversimplifying. There are two hooks, okay? There is the container that is the OCI spec, and there is the special case for the Kubernetes, the sandbox hook, right? If you hook into the sandbox, is when the queue call run pod sandbox, it creates the network, calls CNI, and comes back, right? At the moment, you don't have even a container. You only have a namespace and all the C groups and all the stuff, right? At that part, everything is blocked, right? So it's two calls. Then is when the queuer receives I have the sandbox, now I start to create the containers. And these are the other hooks, right? The ones that create the containers inside the sandbox. That's why it's for the networking guys to hook into the sandbox creation thing, because at that moment you don't race with any process or anything. They are not even running containers. They are not restarting. That is a sweet spot we have for networking there.
Mm-hmm. Okay, that's good. So no race condition.
Okay, so to summarize, since you guys use hook into the create sandbox, which is before the container starts, we can assume that the metadata.json will be present, and the presence of that file can be treated as that this driver supports the downward API. Is that correct? Okay.
Sounds
okay.
like it.
I think then we can consolidate on that and remove all the stuff with the supported and go back to the presence of that file being the source of truth, whether we support it or not.
Awesome. Okay, we have like 2 minutes left. Antonio, I think you have another agenda item.
Yeah, it's a quick thing. It's because we are growing, and Lionel was supposed to have this EasyCap that was adding the status to the resource claim status, right? And it ended with all this discussion with us. I spent a lot of time in KubeCon trying to gather consensus of this, because I'm afraid that we leave this in perma-beta. It was supposed to be an EasyCap just to consolidate the network information, and I really want to get some eyes. I have the implementation. There are some questions about testing that I had with Patrick that I think that I didn't sort out. But I just want to encourage all of you, if we can graduate things and avoid this perma-beta, because, it's in this release, I'm still going to be able to do it. It's after this release, I don't know, and I don't know if anybody else is going to be able to take on this.
Okay.
I consulted with the main stakeholder, that was Jordan Legit, and I never remember the name. ENG. What is the? Okay, I don't know.
Mo, is that Mo?
Yeah, I think it's Mo. Yeah,
Mo. Sorry, I'm after holiday season, and I'm not able to put in it. I consulted with them. They are fine with the solution, and so please, let's try to get this in GA and close another case.
Yeah, let's try and get this done like before the cycle gets too heavy. Okay, awesome. Thank you, Antonio. Okay, we are out of time. Thank you, everybody. And we will see you in a couple weeks, or next week for the people in the in Europe. So, bye-bye.